All right, everyone, I'm going to do another video to cover some of section 2.1 that I obviously missed in the first lesson, and then there were a lot of comments on Classroom. So first thing I want to review is sine x over x. So this is more 2.1. So this was part of a couple of the different problems, and they asked you to find the limit as x approaches 0 of the sine x over x. And the easiest way to look at this is on your calculator. And if you look on your calculator, it's pretty easy to see graphically why the answer is 1 for the limit as x approaches 0. Algebraically, it's a little bit complex, so for right now we're just going to look at it on your calculator. You can go from there. There were two homework problems that there were questions on, number 31 and 33. So let's take a look. 31 is the limit as x approaches 0 of the sine of x over 2x squared minus x. Okay, so limit as x approaches 0 of the sine of x over 2x squared minus x. So there are a bunch of properties which are on page 61, bottom of page 61, top of page 62. You can copy them down into your notes if you want. I'm not going to go through every specific property, but there's a product property, a quotient property, a product quotient sum, difference, etc. And we'll look at those more as I go through today. But again, those are listed on the bottom of page 61, the top of page 62. So I'm going to look at this as the limit, as x approaches 0. And I'm going to separate this into a product, which is going to be the sine of x over, first let's factor. First we're going to factor, and then the sine of x over x, which we just did right here. So I'm going to write this as the limit as x approaches 0 of the sine of x over x times 1 over 2x minus 1. This right here is 1. So this becomes the limit as x approaches 0 of 1 over 2x minus 1. Plug in and you get negative 1. All right, let's take a look at number 33 it was. Okay, so number 33, which was the limit as x approaches 0 of sine squared x over x. Okay, so again, this is 33 from the homework. Well, I'm going to do pretty much what I did for number 31. I'm going to separate this as sine x times the sine of x over x. Well, as we've done in 31, and as you can see from your calculator, this is 1. So you're left with the limit as x approaches 0 of the sine of x, which is 0. How do you know that? Sine curve, right? 2 pi, 0, etc. So that's number 33. Okay, I'm gonna touch on a couple other things that did not cover yesterday. So again, look at the bottom of page 61 and the top of page 62. There's all kinds of properties in there. Okay, so this is number 56 from the book. Just gonna use the examples or problems from the book rather than make them up myself, because if I make them up myself, it won't go so well. You are given that the limit as x approaches, I think it's b, is it b? Yeah, of some function x is equal to 7, so that's given information. And you're also given that the limit as x approaches b of some function g of x is -3. Okay, so we're going to use this information for the next several parts of the problem. You are asked to find the limit as x approaches b of the f of x minus the g of x. And this really is as basic as it looks. The limit as, let's just go back here. The limit as x approaches b of the f of x is 7. You're not distributing, it's a property. You're not distributing the limit. It's like you don't distribute logs. Logs are a function. A limit is represents a certain place on a function, let's say. And then g of x is -3. So 7 minus 3 is, do I have it written down right? Okay. Let's say you're asked to find the limit as x approaches b of 5 times the g of x. So this is 5 times the limit as x approaches b of the g of x, which is going to be -15. So there's a sum, difference, product, quotient, power, and I think there's a constant property as well. So again, go to the bottom of page 61, top of page 62, and hopefully that will, I think this part's pretty basic. I know that there were questions about the graphing, which the sine x over x, which hopefully I explained. All right, the last one that I want to go through, graphing. So we're going to do a piecewise function, which I know can be difficult, and on top of it, we're going to throw in trig functions. So while I erase, graph g of x equals secant. Review the graph of g of x equals secant. So cosine and secant are reciprocals. They're not inverses, they're reciprocals. So I always start with the cosine graph and I construct from there. So a cosine curve. I'm just gonna, here we go. My drawing has not gotten any better. Okay, so secant is reciprocal, where the cosine is 0, the secant is undefined. Where the cosine is 0, the secant is undefined. So, undefined asymptote. That's your generic graph of secant. That's your generic graph of secant. we usually have the parent is the function which goes through, which touches the y-axis. So this would be your parent. I know it's pretty messy. So we are going to do piecewise involving secant curves, cosecant curves, etc. So this is a very basic secant curve. All right, so I'm going to give you a piecewise function. We're going to graph cosine and secant. Is it negative? Is it included? Yeah. I'm going to put these two pieces together. All right. I'm going to erase as I go. Put negative pi on there because that's where I'm asked to graph from. Okay, so I'm going to graph the cosine curve and then I'm going to erase the parts that are not needed for this particular problem. So cosine. Ish, give or take. So from negative pi to 0. And 0 is not included. Okay, so there's a cosine curve from negative pi to 0. 0 is not included. And then I'm going to do a secant curve from 0 to pi. Okay, so here's the issue. There is an asymptote, let me erase this better, at pi over 2. Why did I fill in? It was an open circle. Why did I fill it in and make it a closed circle? Because 0 is included for the secant curve. So now we're going to talk about limits and right-hand side and left-hand side limits. Let's see, let's do, sorry, I'm in my garage if you haven't figured it out, and there's a motion light, so half the time when I walk back, it turns on, it turns off, so I know it's not perfect, I'm working on it. So, let's talk about the overall limit of this function. So how about the limit as x approaches 0, let's say, of this function? X approaches 0. Okay, so that means as I approach from the left and I approach from the right, I should end up at the same point. I should be approaching the same point. So from the left, if I approach 0, I'm on my curve. The y value that I am approaching is 0. Again, I'm on the curve, I'm going up my cosine curve, and as x approaches 0, y approaches 1. Similar when we do like increasing and decreasing, it's not an ordered pair, it's the y value, 1. Okay, now as I approach from the right, so as I approach from the right, I'm coming, I'm here, and I'm hitting my curve right here, and I'm going down. But then I have this asymptote. Pi over 2, though, is not 0. I'm asking you what happens when x approaches 0. As x approaches pi over 2, that's one thing. But pi over 2 is not 0. I got pi over 4, pi over 6, pi over 12, whatever. So I am now up on this part of my secant curve. So I think of it like I kind of jumped. I was on this part of my curve, I hopped over the asymptote, I'm here, and I'm going down, and I'm approaching 1. So the limit as x approaches 0 of this function is 1. Okay, the next problem is overall limits. Overall limits. So I'm going to ask you, where does a limit exist? Where does it cease to exist, etc.? So here are the key things you should look at. Here's the starting point of the graph. That's important. Remember, this whole function, this whole thing is a function, not just boom, boom. We took 2 pieces to create the whole function. We took a piece of a cosine curve, then we took a piece of the secant curve to create this overall function. Okay, so we took 2 pieces of 2 different functions and we created a new function. Here is another endpoint of the graph. Look at your domain. Negative pi to pi. Negative pi to pi. And then there's this problem with this pi over 2 asymptote in the middle. Problem with the pi over 2 asymptote in the middle. Undefined, asymptote undefined. It's going to affect our domain. So I know we're talking about limits, but we're here, let's throw that in. The domain. Hopefully I've done that right. Hopefully I have my brackets and my parentheses right. There's my domain. This is actually going to help us when we're finding right hand and left hand limits. Remember, from the left, this way. From the right, that way. So I just want to ask the same question. Let's see, you were asked to find the limit as x approaches c from the left. So generic question. I want to know the limit as x approaches some constant. The some constant, we're going to call it c. In calculus, you're going to see c a lot. You're going to see c a lot. How do you like that? No 1. Okay, so as I approach from the left, you're going to have to look at the exact wording of the problem. This is like 62, I think, and it asks you, where does the limit cease to exist? I'm pretty sure that's the question. Where does the left-hand limit cease to exist? Pretty sure. Well, boom. Sorry, I don't know the exact question. I don't have my book with me. So, as I'm coming from the left, I can have a limit, I can approach infinity, I can approach negative infinity. Exact value doesn't exist. Limits are approaching. So as I'm coming from the left, I approach up to infinity, I'm down here. This is the end point of the graph. The limit can cease to exist at the end point of the graph. So when x is pi, exists as x, for values x is equal to pi. That's not the best wording. The limit as x, the limit exists up until, we'll just say, I'm just gonna say up until, I'll give you better, that's not great math language, but we'll figure that out. From the right, what do you think that's gonna be? The limit as x approaches from the right of this function exists, I'm coming from the right, until x equals negative pi. Okay, so there's 2 things, I hope. At the beginning of the video, I went through sine x over x. Again, look at your calculator. That is the best way to go. Look at your calculator. Well, will we be allowed to use calculators on our quizzes and tests? Well, right now I'm not even sure there are going to be quizzes and tests, but part of the AP exam definitely involves your calculator. And then I did the beginning 31 and 33, which were homework questions. I've seen a lot of those on Classroom. Keep posting your questions on Classroom. It's a fantastic way for me to see what I need to go over. Your classmates are helping you out. And then this, the first part about the properties, which I said were on the bottom of 61, top of 62, and then graphing some piecewise functions. Okay? Keep those questions coming. I will see you guys soon.